Good afternoon, everybody. Welcome to, Trimble RealWorks introduction and demonstration this afternoon. My name's Steve Anthony, and I'll be running you through a very brief introduction on RealWorks, and then we'll leap into more of a hands-on demonstration type presentation. So just briefly on Trimble RealWorks, it's a point cloud processing and analysis software for 3D laser scanning. It has automated tools and point cloud specific workflows that allow users to import point cloud data from virtually any source, quickly process, analyze, and create high quality deliverables. We have a few different versions of RealWorks. So we have a few different versions of RealWorks available. We have Trimble RealWorks Viewer, which you can see a download tab here on this screen. We also, which is great for customers to just be able to view data and take a few basic measurements and the like. And then we have our full RealWorks suite, which is RealWorks Base, which provides basic point cloud registration, navigation and viewing, surface creation, volume calculation, and orthophoto generation. Then we go up to Advanced, which is probably the most common version that's out there on the market. It includes automatic registration for both target-based and targetless projects, automated object classification, advanced drawing tools, complete set of surface-to-surface and 3D inspection tools, as well as the ability to publish projects, and includes all the tools that are already available in Base. And then we go up to Modeler, which is basically RealWorks Advanced, but it also adds models to your point cloud deliverables with fitting, extraction and editing of common shapes. It also provides specialty tools for modelling plant-specific objects, including rails, cage, steel beams and stairs. We also then have a module called Advanced Tank, which has all the tools included in it in Advanced Modeler, plus some highly automated tools dedicated to storage tank inspection and calibration. Creating reports from scanning data easy, even for the non-scanning professionals. It's a very specialised module for tank scanning and calibration. So, without further ado, I'll jump over into Trimble RealWorks, and we shall jump into it. So, when we open up Trimble RealWorks, we're greeted by a start page. In a lot of ways similar to, some ways to what you might see in TVC with this ribbon type layout. It's also, some of the tabs are similar. We check for updates, license manager, online support, link through to some YouTube videos as well, and an online help command there as well. So, basically, up the top here, RealWorks runs in two main configurations, one being registration and the other being production. So today we're going to try and get through a lot of the stuff in the registration configuration, and then at another presentation, I think it's sometime after Easter anyway, we're going to have another one where we look at the stuff in production. But today, registration. In the registration mode, we have these tabs across the top of the screen here. And firstly, obviously, we're going to want to import some data. And then once we've dragged some data in, we'll jump over into this registration tab, which is where we do most of our work in here. So firstly, I'll bring some data in. So just import. So firstly, it's important to note that this data was from a TX8, so a Trimble TX8. And as such, it's stored. The data is just stored on the USB stick on the scanner as a RealWorks project with the RealWorks folder. So it's simply a matter of just copying and pasting that off the stick onto your hard drive and then importing it. It's already there as a RealWorks project. So we just open that up and in she comes. So over on the left here, this is typical of what you would see. So we had this particular job, we had 4 stations, and at the moment it's telling me here that we've got 0 points. That number there purely represents the number of points in the cloud that we're looking over here in the display section of the screen. So if we actually, which is 0 at the moment, if you turn the station markers off, there's absolutely nothing there. So if I dig further into these, we can see that there's actually, 64 million points in that one particular station there. So we can extract those points out of these are TZF scans, so we can extract points out of those as we see fit, and there's a number of different ways of doing that. So what I'll do, just so we can have a look at some unregistered data on the screen before we start putting it all together, I'll just extract some data out of those TZFs, and one of the ways to do it is this tab here. It says create sampled scan. So if I hover on that, I'm not sure if you guys can read that, but it basically says extract subsampled scans from the TZFs. So that's what we want to do. So if we click on that, there's a few different ways of sampling the data from the TZF. Commonly, probably sampling by step and spatial sampling would be the two that you would use a lot. In this case, I'm going to use sampling by step. So what that means is that if I put this step number down here to 1, it means that it will extract all the points available to me, 128,700,000. So everything that lives in these TZFs over here. If I take it out to 2, it'll divide it by 4. If I take it to 3, it'll be 9, 16, 25, and so on. So you can basically decide here, what you want to have a look at as far as the points go early on, just to make sure your registration looks okay and all that. I usually find 1 million or a couple of million points per station, is good for that kind of process, and then I can pull more out later as I need to. So I'll run with 4, which will give me about 8 million points in total. So I'll just run with that. So it's now ticking through those TZFs. So what it's doing is it's extracting every 4th point horizontally and every 4th point vertically out of the grid. So they will end up with, as I said, 1/16 of the overall number of points. So you notice down here it's saying there's 6 scans, where we've only got 4 up here, stations. So a couple of these stations must have more than 1 scan in them. I'd suggest the last 2, station 3 and station 4, have got a couple of scans from the one station. So that's done now, and you can see we've pulled out a few million points. So just to confirm, so these ones have got more than 1 scan from the station there. So, so now if we look at that data, we've got points extracted from the TZFs, but it's just a bit of a mess there. It's just unregistered data. And it's also just on an arbitrary data, moves beyond 0, 0. Yeah, close enough. So we've got to there's a few things we have to do here. We have to bring this data together, register it, and then we need to geo reference the data and get it on our datum, which in this case was MGA. So firstly, to register the data. As I said, I'll come back to some of these other tabs here. if and when we get time, but commonly a lot of these processes are also available over in production mode, and we might deal with that in the next presentation. But most of the stuff that we're going to be doing in this configuration is in this registration tab. So once I've imported it and I've extracted some points, which is what I've done up till now, I get these different options to register the data. There's basically three main methods. One is scan-based registration, which, as the name suggests, basically stitches the scans together using cloud-to-cloud methodology. Target-based registration, where we commonly use targets like spheres and checkerboards which can be identified in the cloud and used to stitch the scans together. And then we also have survey workflow. So this is your more conventional type station setup where we're occupying a station with a known coordinate, backsighting a target, that kind of workflow. So firstly, we'll run this auto register using planes, and if I hover on that, it says there below there, automatically register by extracting planes in the scans and matching them. So as the name suggests there, auto register using planes, it needs planar surfaces in order to do that. So commonly, if you're working in and around buildings, structures, especially internal stuff, obviously where you've got floors and walls and roof, ceiling, and then even streetscapes. If you're out in the street and you've got houses and the like, that the software can identify common geometry in the planes within the cloud and stitch it together. In an environment where you haven't got that kind of infrastructure around, you need to come up with another method. But this tool has improved a hell of a lot over the last few releases and is really very, very efficient at what it does. The tool next to it here, cloud-based registration, is a more manual way of dragging the scans together using the cloud, and I'll demonstrate that to you in a second. But it basically allows you to select common points in adjacent clouds and manipulate the cloud so you can get a registration result. So what I'm going to do is I'm going to simulate a situation where I've registered this data a few times before, and I know that it does auto register. But for this exercise, what I'm going to do is I'm going to just select the first three, just to simulate a situation where scan 4 didn't auto register, and we ran it and it didn't get a result, so we have to come up with a bit of a plan B to get scan 4 into the registered cloud. So if I run those three, I hit auto register using planes. So that'll tick through. Again, this is using the full TZF scan available to it. We could do all of this process that we're doing now with 0 points over here on the screen to look at. Not that you would, because you want some visual, but that's the way that the process works. So don't be worried about how many points we've pulled out here. You think, oh, I've only pulled out 1 million points, it won't have enough to stitch it together. It's not the way that it works. So it's using the full TZF behind that. So it's registered those 3 scans, and you get some pretty basic reporting, as is the case with a lot of cloud-to-cloud registration. You get a lot more with target-based, but when you think about it, there's only so much information it can give you with cloud-to-cloud registration. So it gives us the result, the average residual from one station to the other, the overlapping point, and a confidence level over here, which is basically a weighting. It doesn't really come into it too much in this kind of data set, in a car park out the back of a depot, but it does when we are doing long linear type surveys, scans, be it rail, road corridors, power line, that kind of thing. But that's all we get as far as the information here. We can do, so if I close that, we can see now we've got registered data. I'll just turn off the station marker 4. So station 1, 2 and 3, and we're all registered, okay? So now we've got this situation where, simulated as it is, that station 4 for whatever reason didn't auto-register into that group, so I'm going to have to get it in there somehow. So all we have to do is select our group that did register and the station that didn't, come back in here, and then we come across to this next tool, cloud-based registration. And if we run that, sorry, I'll just turn my station markers back on. We come into this tool here, and this is quite a robust tool. It's really, very, very good for dragging the data together in a lot of instances. I mean, some guys prefer to use this instead of the auto register, and they'll just bring the scans in one at a time rather than mass crunching of them. Depends how many scans you've got to guess and how much time you've got on your hands. But in here by default, you'll notice it gives me this little pencil picker thing, and I've got the reference cloud over here, which is the one it'll hold still, the red one, and the green cloud here is station 4, which is the one it's going to move. And if I hover on this window down the bottom here, it gives me like a real-time update on how it's going, stitching it all together. And at the moment, you can see it's all a bit of a dog's breakfast there. So if I come in here, and this tool is really, it's to give the registration process just a bit of a heads up. It's not about picking the exact same point in both scans. Generally, it only needs one point just to, give it enough information for it to get, and okay, I've got it from there. So it needs to be just roughly the same point. And you can see here that we got a result. Let's have a look down the bottom. Okay, and now we've got station 4 registered to the auto-registered group that we had there before. I can dive in here before I apply this and do a visual check on my registration. So, and like a lot of these tools in RealWorks, it kind of steps you through it. There's step 1, do this, step 2, so on and so forth. So, if I just wanted to cut a slice through here to see that my two lots of data are lined up okay, you generally want a building or something like that. So I'll just hit that, and then I can analyse that a bit further. And make sure that we haven't got any like shadowing or steps or anything else in the data, and that all looks really good. We've got a lot of the red and the green point cloud data there lining up. So if I'm happy with that, I can close it, and then I can hit apply, close, and you'll now see that station 4 is in our group. Okay, so we've now got a fully registered point cloud using the cloud-based registration tools. So on this particular job, we also had out some targets, so I can show you some target-based registration as well. We had 140 mil, 139s, I think, spheres scattered around the place. So I'm just going to undo this registration, go back to where we were. Yeah, so we're now back to our unregistered point cloud, but this time around we're going to register it using targets. So, pardon me, again, if I select the project or the stations that I want to register, but I want to do all of them, so I just select the project, and I hit registration. We're over in this section now, this time, target based. So what it'll do is we've got to go through and extract the targets, and then it will, once it's done that, it will automatically jump over into this target-based registration tool and give us a result, hopefully, if it gets one. So I'll select this auto extract targets. We didn't have any black and whites out on that job. We don't need to generate a preview scan, and the spheres were the 139s. Okay, so I'll hit OK on that. So again, this will tick through the full TZF scans, trying to identify what it figures out to be 140 mil spheres, and use the position of those spheres to register the scans together. It's worth bearing in mind when you're placing targets out, be it spheres or checkerboards or whatever, RealWorks needs a minimum of 2 these days to get a result, like in adjacent scans. So ideally 3, but you can get by with 2, obviously if there's a height difference between them. So that came in a few versions ago, which is nice and handy. Once we've done this and we get a registration result, we will look at the Geo Referencing part of it after that. So it's just ticking through now. Okay, so we could slice and dice the report here. Well, I'll export a report actually, just to show you the difference in what we get. So you can see there, compared to what we got with our cloud-to-cloud registration, we get a lot in the way of reporting when it comes to our target-based. So we get a station-based result, and then we get a target-based result down the bottom here with our residuals, X, Y, and Z, fitting errors, and overall residuals for each station and each target. We can, if there's a particular target in here that we were unhappy with, if it was giving us a bad residual, we can come in here and select it and simply hit unmatch, and it will take it out of the solution. So you can muck around with it, and to get the best. But we got a good result anyway, so I'm not going to worry too much about that. So I'll close that, and as I said, it's extracted the spheres, and it's automatically taken us into this target-based registration tool. This screen here is telling us that station 1, it found 3 spheres. It used 3 spheres to register the data. Station 2 had 4. Station 3 had 2, and station 4 had 4. So as I said, we need a minimum of 2. So station 3 really only just got a result. But if it didn't, and we wanted to go in and kind kind of identify some of the spheres that we know were there, but for some reason the software hasn't found them. We can, just as I said, from step 1, we come down to step 2, and we can go into analyze. So in here, it's found some spheres, which is great, but I know that there was one over on the wall here. Not that we do need it, but if an example that we did, I can come in here and I can tell it that that's a sphere that I need to use in our result. Station 4, same deal. I was a little bit surprised it didn't automatically find that one. I think maybe it was something to do with the reflectivity of the surface that it was on, perhaps. But yeah, that's quite clear there. You'd normally expect that to be extracted, but in the case that it's not, it's no big deal. We can just extract it ourselves. So if I click on that, I've told it here that it's a spherical target and it's 139 mil, and it gives me a result here of how many points it got on there and the standard deviation, and I can create it. I've now got a target there, and then if I come back to station 3, and same deal. That looks pretty good. And yeah. So I've now just extracted my extra targets. If I rerun the adjustment on that now that I've got those extra targets in there, yep. You'll now see at station 3 has got 3 targets. Okay, I only had the 2 there before. So I can pull out targets as I want. You can also, as a really kind of, it's the last resort kind of method. We can also extract, as well as spheres and checkerboards, we can just do points. So if you can clearly see, a point on a, you wouldn't do the corner of a window frame like that, but say a bit of signage or something like that, where as long as it was good enough for you to get a registration result for your needs. Sometimes these bottom 2, suffice to do that. But if you've got spheres and checkerboards, it probably won't come to that, to be honest. So once we've done that and we've run our adjustment, I'll hit apply. And you'll see now that station 3 used 3 targets. So I'll apply that registration. Now, because I'm going to geo-reference this data, it's important here, and I'll talk a little bit more about this, that I group it, that I group these stations. So I'll hit group there. And you'll notice that these stations now all live in a folder called new group. I can rename that, whatever I like. But so what grouping does is it basically means that the stations are grouped together. So if one of those stations, for example, got geo-referenced or shifted in some kind of way, the whole lot go together. Whereas if you had them all separately, if I was just in here and I was just selecting that, station 2 would just shoot off into the distance and the rest would be left behind. If you want all the data to go together, basically you just group them. Okay, so when we geo-reference this, obviously I want the whole lot to go, so put them in a group. So now we're at a point where we've got target-based registered data, and we want to get it onto in this case, MGA. So if I have a look at that now, we're still on these coordinates, which are just a distance from station 1, basically. So the way that we do that, again, there's a number of different ways. We import survey control file.
So change that to a surveying ASCII text file. And that one there. And it's just point number, XYZ, tab delimited, yeah. So bring that in. So you'll see now we've got our survey control off in the distance here and our point cloud down here at 0, 0. So, and now over here in the bottom left, we've got our group and our control file. Now, there's a number of different ways of geo-referencing your data, depending on how you've attacked it in the field, basically. So, and I'm going to show you a couple of different methods with different data sets just after I show you this method here. But this particular example, we were on at least 2 of our stations, we were set up over known marks. So one of the workflows that we like to promote to our customers is that you can do 100 scans. But as long as at least 2 of those scans are over known marks and you've got a method to register them, you're done. You don't, pardon me, you don't have to, get out the checkerboards and get out the jigger and start, pinging survey control around the place. If there's existing control on a job, this workflow is just absolute gold. It makes it so easy. As I said, this was done with the TX8, so we just set up, it's either 2 or 3, I'll find out in a minute when we run it, but over known marks. So all I need to do to apply that georeferencing is select those 2 groups again. Now, RealWorks is smart enough to be able to recognise the geometry of our control file and the geometry of our targets and or our stations in our point cloud and apply a best fit solution for the cloud to the control. Okay, we can do it manually as well, and I'll show you how to do that in a minute, but there is an automated function for it. So all I need to do is select those 2 groups and run this target-based registration tool again. Okay, but this time, what it's telling me here is that out of the 4 points we had in our control file, it got a result to targets or stations for 3 of them in our point cloud, and it's telling me there that it had 20 stations and targets all up, but it used 3 of them to georeference the data. So I close that report, but we can have a closer look at that, and again we can go through and remove anything that we, the station 3 seems to be a little bit out. We can muck around with that and tighten it up as best we can until we're happy with that. So if I hit apply on that now and close, and we dive back in here, we can see that it recognised our station 3 was WSO3 and station 2 was WSO2 and so forth. Okay, so now if we have a look at that, we're on MGA. Okay, so that's one of a number of ways of doing it. As I said, it all depends on how you attack it in the field. If we had checkerboards up because we didn't have much control on the ground and we were happy to make the time to get the jigger out and ping some checkerboards and stuff, it would be a slightly different workflow, which I'll now bring up another data set and run through with you. So it's pretty straightforward. It's just a matter of when you're out in the field being aware of how you're going to register it and how you're going to georeference it. And it's all pretty straightforward from there. So I'll close this job. And I'll bring in one This one. So this was just some scanning that we've done out here at Campbelltown, probably the most scanned building in all of Australia. So just to show you a different way of georeferencing the data, you can see it's already registered. It's a big warehouse, so obviously plenty of planar surfaces. So it suggests that we did a cloud to cloud registration on that. I've now imported a control file, but this time instead of running an automated georeferencing process, I'm going to do it more manually. Okay, so if I select those, select that group, I'm going to go to a station view, and I'm going to go to, right, yeah. So what I've done up to this point is all I've done is import my control file. I've come in and I've gone auto extract my targets, which in this case were black and white checkerboards. So we just had stuck on the wall around the warehouse here. Okay, so if I run this little georeferencing tool, brings me into here. So it's target 75. So if I select it, I can either select it from here or from the list over here, and I go by target, and then it gives me the drop down of all my control. So like you need to be aware of what checkerboard is what point, but target 73. So what this does, even though it's a little bit more manual way of doing it, it gives you a bit more control over that. That previous method I showed you was, pardon me, very much an automated kind of method, and you got a result at the end. You can then go in and edit it, but this here, you see down the bottom here, as I'm doing it, it's giving me the residuals and the, pardon me, a tick box next to each one. I've only got 3 in this particular data set, so I can't really, but you can, obviously delete, untick the ones that, you aren't getting the best result for until you get it as tight as you can. And once you're happy with that, you can hit apply and close, and you're done. Okay. As I said, the beauty of using this method is that you've got more control over what's going on there. And you can also be more, like if depending on the accuracy of the results you're looking for, you can decide what residuals you're going to accept and what you're not going to use. Whereas in the automated way, it kind of has tolerances there that it won't process outside of. So in here, you've got total hands-on control about what you're using and what accuracy you're happy with. Okay, so that's another way of georeferencing your data. I'll just close that. And I'll bring in, because I just want to show you, so we've basically been through scan-based and target-based, including the georeferencing aspect of it. And lastly, I just want to have a quick look at this station setup option. So, haven't really got, I've got a, this one here is probably, okay, that'll do. So, yeah, so you can see here, we've got two stations, unregistered, ungeoreferenced, uneverything. So we'll run through how to use that survey workflow tool. So I need to import a control file again. This time they're not grouped, okay, because we're just going to be doing one at a time, like we're traversing through. So text file, Okay, so same deal, we've got our control over here, and our point cloud over here, and so we're basically in this workflow going to be traversing, okay, but not traversing out in the field as such. Well, we've done the field work, but we're actually applying the traverse in the software. So if we come into station setup, and we've got some targets out on our back sites in this particular example. So over here on the right, it will automatically take me to station 1. It'll have the instrument height there. This is a TX8 once again. So in the TX8 in the firmware, you can actually enter the instrument height in the field, so it'll just auto-populate into RealWorks for you. And so we just need to tell it what station we're set up on out of our topo file, which was S2. And what we want to use is a back site, which is this little target here. We got set up over another mark, which was S3. And apply. So you'll see, because I've only done the one station, it's shifted 1 over onto our datum for us, and 2 is still living off in the distance over here. So we'll go in and do the same for 2. Now, importantly, when I did station 1, as you'd expect with a traverse, I guess, but when I did station 1, I had a foresight out as well. Okay, so this mark here is where I was planning on having my next setup. So I just had a sphere set up over the top of that. Okay, so and it's called target 4. So you'll see how in here now, I've got station 2, instrument height. Where are you set up? Well, I'm set up where target 4 was. Okay, so we're just off traversing now. We've set up on 2 backside of 3 and we're off. So hit OK on that. Target 5 is now set up on station 2, where we were with the instrument to start with. Apply. And we're all good. So station 1 was here, backside to here, foresight to there. And then station 2, I just backsighted that and scanned. I didn't keep going, I didn't have another foresight out, but I could have. And we could just keep going like that, leapfrogging along. So that's another way of doing it. If you depending on the options available to you out in the field. So that's survey workflow. So basically, all the registration options and georeferencing are covered in this tab here. So I think, next time we have a look at RealWorks, we'll be, as I said, then once we've got this data all stitched together and georeferenced, we'll be jumping over into the production mode, which offers a whole other range of tools, and there'll be a bit to cover there. But I think for today we've probably covered off the critical stuff in the registration tab there. If anyone's got any questions? Okay, everyone good? My email is there if anyone would like to follow up with anything afterwards. Please feel free to send me an email. As I said, we'll dig a bit more deeply into the RealWorks production mode after Easter. So have a happy Easter, everybody, and keep well. Thanks for your time.